Okay, thank you for joining me. So my name's Charlie Pilgrim, and today I'm going to be talking about publishing Python packages, or more directly, my experience with publishing a Python package. So I'm a PhD student, third year at the University of Warwick's Mathematics of Real-World Systems CDT. So I'm quite happy to be joining the Hetsys CDT today. I think it's good to have cross-communication between the CDTs. I'm also an enrichment student at the Alan Turing Institute currently, and a bit of my background, I was a software developer for a few years, so I have some experience with creating production-ready code. And so as part of my PhD, we came across this problem which we couldn't solve with the existing tools in Python, and so we made our own version and published it. Essentially what we did was we ported a package from R into Python. It does exactly the same thing, more or less. So hopefully today from this talk, you will learn a little bit about publishing Python packages, obviously. Obviously, I don't think most of you maybe won't actually publish a Python package, but I think it's useful to know about it anyway, just to give you a feel for how the ecosystem works. And there's a few things that you can learn during this talk that will certainly be applicable to sort of any kind of coding software challenges you have in the future. So to give you a bit of background about the package itself, this talk isn't about the package, it's about publishing the package. But I think it's obviously useful to talk to you a little bit about what the package does to give you a bit of background. So the package is called piecewise regression, and I'm going to show you an example of what it does just now quickly. So first of all, the package can be installed. This is a Google Colab notebook just to sort of give an example of how the package works. The package can be installed quite easily with just a pip install, which is a standard way to install Python packages, and it can be imported just like a normal package as well. So what it does, the package, is it tries to fit a straight line model to some data, which we can scroll down a little bit to show here. So we have some data, which are these grey dots, and we're trying to fit a straight line model where there's a change in gradient. So the y variable is continuous, but it's discontinuous in its first gradient. So you can see that there's a change in gradient, but it's at the same point, and the package estimates the gradients and line models of these two sections, but also estimates a position of the breakpoint where the gradient changes. This is the common problem that you might have to solve in a whole range of different fields. So they use it whenever you're trying to find some kind of phase transition. You might want to use something like this, or if you're looking at, say, a medical intervention and you want to see a change in a population, you might use this kind of method to try and detect where that happens and the extent of the change. So it's a very common problem which is across all different fields, and this tool does this one thing very well. If you have a quadratic line or something like that, it doesn't work. It's only for straight lines. Okay, and we can also have more than one breakpoint. So this is with 3 breakpoints, and here the data are these blue dots, and you can see it fits these 3 different breakpoints, changes in gradients, and you can see that the third breakpoint here has more uncertainty because the change in gradient is smaller there. So it kind of calculates all these things automatically for you, the package does, and it gives you uncertainties and standard errors and all those kinds of things. So it's quite a cool package, I think. So going back to the presentation, we released the package, or I released the package back in December. So it's on GitHub. We currently have 23 stars, so 23 people have favorited the repo, which is quite good, I think, after a few months. It can be installed with the Python package index, as I showed before, with pip install. And we released a paper to accompany the package in the Journal of Open Source Software. This is a really good journal because it allows people who, if you published a package, it used to be the case that it wasn't necessarily easy to then cite that package if you used it. So from an academic point of view, everyone's interested in citations. The Journal of Open Source Software allows you to publish a small paper accompanying a Python package or any other package, and that allows you to people to cite the paper when they use the package. So it gives you citations, which is good if you want to be an academic, obviously. Okay, so today we're not going to talk about the actual package itself. We're going to talk about the process of publishing it. And essentially there were a few steps. So first of all, we have version 0, which was identifying the need for the package in the first place. And then I want to talk about getting from 0 to version 1, where we had a basic working prototype. And then version 1.2.1, which is the current version, which was also the version associated with the paper. So I'm going to go through these steps one by one. Okay, so a little bit more background into the kind of problem that we came across. So my supervisor is Thomas Hills from psychology, and so we do a lot of work with linguistics and studying changes in language. And there's this phenomena in language called Zipf's law. I'm not going to go into it too deeply now, but essentially it's the distribution of words that you find in a book or a large collection of text. And about 10 years ago, it was discovered that actually this law changes at some point. So after about the first 1,000 words, most popular words, the word distribution seems to change to a different regime, and it has a different gradient in the probability distribution. So we wanted to investigate where this change happens in different selections of text. And we wanted to do this very fast. So we had thousands of books and texts, and we wanted to go back hundreds of years in 10 different languages. So we wanted to run this kind of algorithm very fast. And so I looked around for ways to estimating where this breakpoint would be given some data. And I found a few options. The obvious thing to do would be something like grid search. So you just search over a grid of possible breakpoints, possible changes in gradient, and then you fit models given that breakpoint, and then you do something like minimize the sum of squared errors to find the optimal solution. You can also combine that with numerical optimization algorithms like evolutionary algorithms, etc. All of this method created by Professor Muggio from Italy called segmented regression. And what this method does, without getting too much into the details, is it essentially takes this nonlinear problem, which is the model with the breakpoint, and it applies this Taylor expansion to find a linear approximation of the model. And then we can use ordinary least squares to fit this approximation. And there's an iterative algorithm Muggio came up with to then find the closer and closer fit, and to hopefully converge to the correct answer. The good thing about this method, again, I'm not going to go into too much detail about this. It's just a quick overview. I'm going to talk more about the actual publishing the package. But the method is much quicker than the numerical optimization methods, and it gives you better statistics. So it automatically generates standard errors for the breakpoints and that sort of thing, from which you can then generate confidence intervals, which is very useful. So we wanted to use this method, and it seemed like a good method to use, so why not? We couldn't find a Python package that did it, but there was an R package called Segmented, which was also written by Professor Muggio. That was very popular. This has 1,600 citations, so it's a really good package and it's very well used. But there's nothing in Python. So all of our other code was in Python. So we really wanted to do this in Python. So I wrote a simple version of the algorithm that Muggio described. And I thought, well, maybe this would be useful for other people. Our package has lots of citations. There's also lots of Stack Overflow questions asking for a Python package. So it felt like there was some demand for this. So I thought, I'll do it. I've written it already. It shouldn't be that hard. I thought it would take about a week. But of course, the reality of it was it took a lot longer. So this isn't quite the same thing, but I think this XKCD comic kind of captures the idea of what you think writing the code is going to be, and then actually the reality of it. So it probably took about 2 months. I mean, it took longer than that, but like total work time was probably 2 months. And I thought it would be about a week to begin with. So yeah, these things do take a while, but I think it was worthwhile overall. And I'll go through now the process of getting the package published. So we've identified the need for the package, and now I'm going to talk to you a little bit about the process of writing the package, publishing the package, and getting the first version up and out there. So I wanted to make the package part of the Python package index so that you can write pip install in the terminal and you can install the package without having to download any binaries or anything like that, which can be confusing. So I thought, well, it must be quite hard to get into pip install, because this is like the authority for Python. This is like where all the best packages are. So I had a look at the criteria, and essentially this is the criteria for pip install. There's no criteria. You can just publish whatever you want on PyPy. There's no criteria at all. There is, so if there are security concerns and someone raises that with the package already published, you can report that to PyPy and they will act on that. But to actually publish something, there's no criteria. So I think it's important, it's useful, if you take anything from this talk, to be aware that just because you can pip install a package, it doesn't mean that it's a good quality package. It may be a good quality package, but it could just be someone's random hobby project that isn't well tested, for example. So I wanted to create a package on pip. I wanted it to be a good quality package. So I wanted it to be what we call production ready. So this is partly my experience in the software industry to sort of understand how what I needed to do to get the software from this working prototype on my laptop to a fully fledged package which people would find useful. So it has to be basically correct. It has to be robust. It has to work every single time. Part of that is that it has to be well tested. If it does fail, it has to fail in a way which is graceful, so it tells the user why it fails. So, for example, if the user uses an input into a function that they can't use, rather than just crashing, it has to have a nice error message that says, "Hey, you can't use this kind of input," for example. It has to have lots of documentation so people can understand how it works, and I really want to make it really user friendly. So it would be lower the barrier for people to use the package, and so hopefully get more users and that sort of thing. So in order to get to this stage, I started a development process, and essentially I used a Kanban board. So Trello gives you free Kanban boards, and these are basically, if you're not familiar, they're to-do lists or lists with items that you can move across. So it's really good for software development because you can have a list of features that you want to implement, and then you can move them across the board as you work on them. So you can move it to like done, to testing, to completely done, for example. And it gives you a place to put any ideas you have. You can just put them on this board, and then you can either get to them or forget, or for whatever reason choose not to do them. So the basic loop was to focus on a feature, write some tests to write down exactly what I want the feature to do. Maybe it's fit 3 breakpoints, for example, but then write the test would be, given this data, I want the breakpoints positions to be found at these 3 positions that I know that they are, for example. Write the code to implement the feature to pass the tests, and then where necessary to refactor the code, which I actually did quite a few times, in order to be able to write tests in a better way. So if your code is in like one big block, it's really hard to test it, for example. So breaking it up into smaller chunks is it's a better way of being confident that the code works. And I had because we were reporting essentially an R package, that was really useful because I had the ground truth from this R package. So I could generate data and results from the R package and then use that to test that my package gave the same results. That wasn't as simple as it might seem because part of the algorithm uses a random number. Excuse me. And so the random number generators are different in Python and R. Excuse me. And so you may not get the same result even with the same data, but in expectation you have the same result, so you can run it 1,000 times and check that you have a similar answer, for example. The main challenge with writing the package was, well, the maths involved for Mugio's method is actually quite tricky. So I had to learn a lot of maths and to go through the paper. Just to give you an example, I think I have the paper here. So this is Mugio's paper. So it's a stats paper. It's written like a stats paper. It's very thorough. It's correct. It's good. But it's from my background, it wasn't super clear initially. So it took a long time for me to get my head around it and to work through it and to really get to grips with the maths and the algorithm. But it wasn't, you know, I did manage to do it, so it wasn't impossible by any means. And this is all very good by Mizio. It's very thorough and rigorous. It's really great. But also the algorithm itself was quite difficult to implement because there's actually several levels to the algorithm. So I can show you the code here. I said before that I had this basic prototype working, and basically my prototype was, this is the code here. So the main.py is the main bit of code which does the legwork. And you can see here there are several different classes. This first class is essentially the original version that I wrote, and this is actually a more simple version. So the original version I wrote was about 100 lines of code, I think, and that worked on my laptop for doing my particular, solving my particular problem. But then as I realized that this is only one part of the algorithm, really, you have to, it's an iterative algorithm, so you have to iterate down through, do this sequentially over time, and it doesn't always converge. So I had to build another object on top so that if it doesn't converge, it runs it again with different starting conditions. Or also it can converge to a local optimum without actually finding a global optimum. So I had to kind of wiggle the starting conditions a little bit to make sure it converges to a global optima, or with a high probability converges to a global optima. So I ended up with these three levels of abstraction. And then there's another level as well, which was the model selection. So I implemented a way to choose between models with different numbers of breakpoints. So don't worry if you don't follow that, but the point is that there's these four levels of abstraction. When I first started, I thought there was just this one simple little method. So it was quite difficult to build that in a way and to kind of get to a structure where it all made sense, because these different levels of abstraction have to communicate with each other, so that so this one passes information down to the next one, and to do that in a way where it all made sense and it handled any errors, any false input, any problems gracefully. So it was quite tricky, a lot of back and forth, changing things, going back and fixing things and rearranging things, etc. But now it seems to work really well, and the structure is really sensible, I think. So everything has its place and it's already quite neat and everything. So it was worth it in the end, I think. The other part of the big challenge was writing the documentation. So the documentation probably took almost as long as writing the main code itself. So every single object and every single function has a doc string, and these are written in this particular format, which allows, I'll get onto this in a moment, but essentially it took a long time to write documentation. And the README as well, so the paper itself, there's a paper involved, which we'll get through, which is part of the documentation. There's a long README as well. And then publishing the package was also a challenge, because I had to learn all these different tools to automate. So to publish a package only takes about half an hour. Like from zero knowledge to actually publishing a package, there's YouTube tutorials, about half an hour you can do it, it's not that hard. But to automate it and to also generate documentation, etc., that takes a bit of work to try and learn all these different tools. So for example, setup tools is a way to handle this sort of deployment, and so you have to write these helper scripts here. This has to be this particular format, and then when you send it to PyPy, it will pick that up and be able to generate the PyPy page for you. There's also things with the documentation, so I had to write all these very specific files that all work together to generate the documentation. So there's tutorials for all this stuff, so it looks more complicated than it actually is, but it's still a learning curve, and you have to get through this and work it out. So it's quite tricky. Actually, apparently there's this tool which I didn't know about at the time, but I've since learned about, called Poetry, which apparently handles a lot of this for you. So potentially there's a better tool out there now. But I think it was useful for me to do it in a way which was perhaps not the smartest way to begin with. to learn really deeply or how it all works. So if I use poetry now, probably it would be easier for me because I already know why the problems that poetry is solving I've already kind of dealt with, so it probably would be better that way. Just to sort of show you a little bit about the documentation and stuff. So my GitHub is, the package is available on GitHub here. And through here, you can see links to the documentation. So the documentation is quite clever, actually. So this is automatically generated from the code. This is basically the README. But the clever thing is the API. So all of the modules and classes and functions, it automatically generates this API for users. So based upon the code, you can see here I have in the main fit class here I have this dot string, and this dot string is caught by the deployment process, and it generates this documentation here on this website. So if I were to change this and then deploy it again, it would be updated on this website. So that means that this is like a really dynamic, but also I don't have to keep changing it. It's automatically done, and it's really useful for people, I think, if they want to work out how a function works. It's all here. They can go through this without going through the code. So it's really cool. Okay, so I think we'll talk about the paper. So at this stage, I have now version 1.0 done, and I'm trying to publish this as an article in the Journal of Open Source Software. So as I said, the Journal of Open Source Software is a way for academics or anyone else to publish packages, but also to get a citation that they can give to people. So when people use the package in their work, they should cite the paper accompanying the package. And this paper, for me, it's not actually research. I'm using someone else's method, but it will still give me citations. So this would be useful for an academic career. It would also be useful if you want to be a software developer. Having packages published is obviously a good thing to have. So obviously, if all my papers were just packages, it probably wouldn't look great on my academic CV. But having one or two, I think, is good, and it still adds up to your citation count on Google Scholar, etc. So people will still see that, and it's certainly not going to detract from your career. So to get into Journal of Open Source Software, you have to submit a paper, and then the review process is quite quick. And interestingly, it's done live, well, not live, but it's done publicly on GitHub. So this was my full review, and you can see here all of the back and forth we had with the reviewers, all the discussion, all the issues they raised. So this was the first review, for example, and you can see it all there publicly. And then you can see my responses, etc. It's quite a bit of back and forth, but we got there in the end. And essentially, the reviewers, what they wanted was more documentation, more testing. They wanted the testing to be automated, and they wanted a lot of the code to be standardized to what we call Flake 8, which is a certain standard way of writing Python code, which is kind of having a standardized way of writing it means that if anyone wants to contribute in the future, they can do so, and it's very familiar patterns for anyone who looks at the Python code. So, for example, the line width has to be below a certain amount. So all these lines are below a certain number of characters. So if you had a narrow screen, you could read it. There's a certain number of spaces between classes, there's a certain number of spaces between methods, for example. There's one space between methods. All these kinds of things have to be implemented. So you can install a linter and Sublime Text and go through and just fix everything. It takes a long time, but I learned a lot doing it, and it's actually improved my coding practices anyway. The other thing was that they suggested that I have these automated tests. So when I push to GitHub now, it won't let me push it. It won't publish it if the test don't pass. So I have this little badge here, which every time I push it, it tells the user that the latest version available on GitHub is passing the test. It says how much of the code is covered by tests, and it tells the user all these other things as well. And also has links to all the different areas that people might be interested in. So the review process was, difficult, and it took a long time, but it really improved the package, I think. And eventually we got it published. So this is the paper. It was published in 2nd of December, so 2 months between submission and publication, which isn't bad. We haven't had any citations yet, but it's still early days, and I've had lots of feedback from people. I've had lots of emails, people saying thank you. I think it was quite a common pain point with people that they didn't have this package in Python, or even though they had it in R, so they'd have to port over to R to do the analysis and then go back to Python. So I had a few emails that were just saying thank you for the package. I got in touch with Mugio, who was the professor who came up with the method, also who wrote the R package. He said, well done and thank you as well. That he was glad that it was a Python version. A couple of users raised issues on GitHub. So someone caught a bug that was relatively serious, which I managed to fix quite early on. So that was great. And we've had quite a few stars on GitHub. So we've had 23 people so far favorite the project, which is quite a good sign. That's after a few months. That should keep growing, I think. I think that's about it. So to summarize, publishing a Python package, for me, I found it very challenging but worthwhile. I learned an awful lot about how software is published, but also Python in general. There are loads of tools available to help. I discussed a few of them here, like setup tools, poetry, for example, and there's loads of guides online as well, on YouTube or on blogs. So if you do want to do something like this, then there are resources available to help you. I would suggest that if you do end up publishing anything as a package, why not try and get it published as a paper as well? And the Journal of Open Source Software is a good journal. It's quick, and it's my experience is really good. The other thing to take away is that just because something is on pip doesn't mean it's perfect. Anyone can publish to pip. So just be wary that if you're using code in your research, you might want to test it that it definitely works, rather than just assume it works if it's on pip. Okay, so thank you very much for your time. Hopefully you found this talk useful in some way. If you have any questions, I'd be very happy to answer them. And thank you again.